All right, let's see what the notes are for today with these new, actually, some are review words, and then there's a couple new ones for today. So we are looking at the relationships between angles, and these are called angle justifications because when we're starting proofs here in these upcoming units, we are going to be using these as the reasons, as the justifications for why certain things can be true. So let's look at this first one. This one is called the angle addition postulate. And this says that the measure of angle ABC, so this nice big one here, the measure of the bigger angle is equal to the sum of the two smaller angles that make it. So let's go measure of angle ABC is equal to the measure of angle ABD plus the measure of angle DBC. Now I'm using three-letter names here where the vertex is always your middle letter. So I can call it angle ABD or angle DBA. Both of those work as long as B is the vertex is the center. So the measure of angle ABC is equal to the sum of the measures of the smaller angles. Okay, let's go put one into practice here. Here we want to find this big angle, TQR. So how can I find the measure of that bigger angle? I can say that the measure of angle TQR is equal to the measure of angle TQK plus measure of angle KQR. So I can use this concept to just add this together. So the measure of angle TQR is equal to 47 plus 68. Grab your calculators, add that together, and hopefully you get 115 degrees. How'd you do? All right, let's look at this next one. This next one is called a linear pair. Pair meaning two angles and linear because it's on a line. We know that A and B form two angles on that linear pair and therefore they are supplementary. So A plus B equals 180. So we're going to say that a linear pair is supplementary, and that means that they add up to 180. Now, one thing that has to be clear on a linear pair is that these are adjacent angles. They share a side. So keep that in mind when you're trying to identify them, that this side is shared between both angle A and B. Okay, let's go do an example of what do I do to solve for x with this linear pair. So again, notice that they are both on the straight line, so I can take this first angle, 3x plus 19 degrees, plus this angle, 7x plus 1. So 3x plus 19 plus 7x plus 1, and that all adds up to 180. Now we're going to combine like terms. 3x's plus 7x's, that's 10 total x's. 19 plus 1, that's 20. Subtract 20 from both sides. I'm getting that x equals 16. Now, if they just ask me for the angle, for solving for x, we stop there. If they actually ask me for the angle measures, we need to take this 16 and plug it back in. So for example, 7 times 16 gives us 112, and 112 plus 1 is 113. So this angle measure of 7x plus 1 actually equals 113. And likewise, if I do the other side, 3 times 16 is 48. 48 plus 19 is 67. So I get that the other angle measure is 67 degrees and 113 degrees. It actually looks like these two should be switched, right? Shouldn't 113 be an obtuse angle and 67 should be the acute angle? But anyways, either way, those are your angle measures. Okay, let's go look at the next one. The next one, we have adjacent angles that form a straight angle. So what is this one used for? Well, up here, a linear pair means two angles, and here adjacent angles means more than two. So if we have three angles, if we have four angles that form that straight angle, we now can use this reason. So in this case, we would be able to say that all those angles add up to 180 because they are supplementary. Notice that adjacent angles share a side. All right, let's look at what an example of one of these would look like. All of these things can add up, so we go 2x plus 22 plus 5x plus 4x. All that equals 180. Now we combine like terms. I'm getting 11 total x's. When I subtract 22, I get 158. And when I divide by 11, this time I'm going to round. I get 14.36 on the calculator. Wait, what do you mean, Ms. Sanchez? How'd you get that? So let me show you on the calculator real quick how it comes out. So if I do a 158 divided by 11, we get 14.36, blah, 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 blah. So you have to round it. So we use this approximation symbol because we're stating that it is rounded. And it's okay to get decimal answers. Not all angles are exact. Now, this right here is my x value, but if I wanted the angle measures, I would have to take an additional step. Here, I need to multiply by 4 in order to get that angle measure. So we're going to go 14.36 times 4, and that means that this angle measure is actually 57.44 degrees. 14.36 times 5, this angle measure is actually 71.8 degrees. 2x, 2 times 14.36 is 28.72 degrees. So if they ask you for the angle measures, there's that additional step of taking the x and plugging it back in for whichever one they're asking for. How'd you do? All right, let's go to the next one. Vertical angle theorem. So notice that A and B are sharing a vertex. They are in two intersecting lines. Notice there is no shared side. They are technically across from each other, right? And what do we know about A and B, or vertical angles? We know that they are equal. Vertical angles are equal. Okay, so this one up here is supplementary. This one is supplementary. These ones are equal. So when we're given this, when we go to solve, we're going to take these two vertical angles and we're going to set them equal instead of to 180. We're going to minus 8x from both sides. Negative divided by negative gives us a positive. We should always get positive angle measures, just as an FYI or something went wrong. So 50 divided by 6 gives me 8.33. Again, because I'm rounding, I'm going to use the approximation symbol. Now, if I was just asked for x, I'm done. But if I'm asked for the angle measures, I have to take an additional step and plug in the 8.33 here. So 8 times 8.33 minus 50 is 66.64 minus 50, which is 16.64. And then over here, 2 times 8.33 is also 16. So notice that these should be equal because vertical angles are equal. Why the slight variation? Because I rounded this one right here. If I do 50 divided by 6, and I do times 8 minus 50, then I do get the 16.66. So if I do that repeating, then it comes out to the same. Okay, good. How'd you do? All right, these were technically a review from the last section with just, I wanted to show you have an example to solve. Now come the new ones. These are the new ones for this new section. So corresponding angles are when A is equal to B. So let's put a couple of notes here. These are on the same side as the transversal or of the transversal. What's a transversal, Ms. Sanchez? This line. They are both on the left side. They are in the same spot on the parallel lines. So for example, this is in the top left corner. This is in the top left corner of this parallel line. So A and B are on the same side of the transversal and the same spot on each. This is called corresponding angles. What do we know about these angles? We know that they're equal. So now that I know that these are equal, I'm going to go over here and set the 20x equal to the 4x plus 48. And I get that x is equal to 3. Again, if they just have me solve for x, I stop there. If they want me to plug in 20 times 3 equals 60 degrees. 4 times 3 is 12. 12 plus 40 is 60 degrees. Yep, they better be equal because corresponding angles are equal. How'd you do? All right, next one is called alternate interior angle theorem. So what's an alternate interiors? It means that they're alternate of the transversal and interior of the parallel lines. So on either side of transversal and inside the parallel lines. So these are called alternate interior angles and they are equal. So again, now that I know they're equal, I can go and set these two equal to each other. If they just ask me to solve for x, I'm done. If they want the angle measures, I have to take an additional step. 8 times 3 is 24 degrees for this angle. And then 2 times 3 is 6. 6 plus 18 is also 24 degrees. They should be equal because alternate interior angles are equal. So I'm going to go up here and make equal and equal. All right, same side interiors, our last one. Same side interiors are not equal. Look at how one angle looks obtuse and one angle looks acute. These two, same side interior, are supplementary. Okay, so how am I going to recognize these? They are on the same side of the transversal, kind of like corresponding angles are on the same side, but they are both inside the parallel lines. And we know that A plus B equals 180 because they are supplementary. So now let's go solve an example of this. 2x plus 5 plus 3x plus 15 equals 180. Combine like terms. If they were just asking for the x, we would stop there at 32. But if they ask me for the angle measures, I need to plug it in. So 32 times 2 is 64 plus 5. I get 69 degrees for this inside angle. And then 3 times 32 is 96 plus 15. I get 111 for this angle. If I take 111 plus 69, it equals 180. And we're done.